Good. So, I think the room is sufficiently filled, and I'm sufficiently excited to announce Thomas Rösler from W3C, and he's one of our front runners in Europe when it comes to the web and standardization. And if somebody knows what is happening in the browser, then it's him. And also, so if you take a national event like the German OWASP Day, and you take it to the European level, you think about the last 5 years of conferences, you think, okay, what worked very, very well? So what would be our best of? And one name that came up in this discussion was always Thomas, because Thomas gave a closing note a couple of years ago, and this was the most discussed closing note for months to come. And so we said, okay, let's see if he can do it again, and therefore, with no further ado, Thomas.
Thank you, Martin, and I think you are all very happy to have one of the European frontrunners in flattery among your conference announcers. Thank you for the gracious introduction, entirely undeserved. But since you mentioned that OWASP talk a couple years ago, the slide that I led with there was about a story that is getting stale. And the story that is getting stale is about how all those applications are moving to the web, how enterprises are using the web, how the notion that we somehow need to protect some asset on a local machine from web technologies really fails because there are no assets left on the local machine. What I talked about there was actually with this slide about how the platform gets increasingly simple by adding all sorts of new technologies. Web Security 1.0 just has a little server here and perhaps a firewall and then a very simple browser over here. Instead, we are seeing technology getting added to the browser. We are seeing plenty of new capabilities that we are still actually working on standardizing, things like WebRTC, where we add peer-to-peer communication between browsers. Think Skype as a web app without having to install anything new. We're talking about Hi-Bye, aka WebSockets, a protocol with API that is meant to enable interactive applications and build new information flows between browsers and servers. We're talking about post-message, channel messaging, and all of that is, of course, what you heard about yesterday and what you will continue to hear about today. All of that is plenty of job security in the web application security field, because really what we're talking about is assets in the cloud, attacks on the web. And really, web security is out. We're talking about web application security. That is too simple. And that is the topic of today's talk. We're talking about how we're actually having it all with the web as a platform, with the web as an application platform on which we are building. I want to talk a little bit about things like Firefox OS, about other web-based or web application-based operating systems that we're seeing. This one, for example, where they're just throwing massive amounts of money at people writing web apps for it, is equally meant for tablets, TVs, mobile phones, and cars. And I'll come back to that. I want to talk about what sort of change to the ecosystem it means when we have computers that really only run a browser and only run web applications. I want to think a little bit about the TV set with a browser in it, and the car with a browser in it, and your head with a browser on it. And perhaps with something that interfaces with the web and that you step on, or that you wear, or that otherwise follows you around. And about JavaScript as a programming language and a programming platform that you can build interesting things with. Tessel is something that's about to come out and is starting to bubble up in public. It's a microcontroller for you to play with, and this one you actually program in JavaScript. When you have Node.js installed, you can connect it to Arduino extension boards and have plenty of fun with it. And I think that's just an example to really show that HTML5 and JavaScript as an application platform is going everywhere. And that's actually the way we are often thinking about this change and about this move of the web as the predominant development platform, as the platform that we use in plenty of places. And if we look at that from a security perspective, a story that we often hear is that we need to think more about how to use HTML5 and JavaScript for trusted applications that are somehow perhaps published through an application store that has reviews. The reviews will catch a lot of the bad stuff, and because the App Store actually attests to some of the quality of the application, attests to the application coming from a trusted developer, we can then give the application access to device features. And in the context of a cell phone operating system, for example, where Firefox has this wonderful slogan of have it all, what we're talking about is access to functionality like the cell phone in the cell phone. The dialer app is written in HTML5 and JavaScript. The SMS app is written in HTML5 and JavaScript, and there could never, ever, of course, be any cross-site scripting in an environment like this. That's almost an environment that we understand, and where perhaps we can draw the line between the trusted application that really is part of the operating system and ships the dialer and some other stuff. It gets more interesting if the platform that we're running our web applications on gets wheels, and I don't know, I'll have to apologize for the brightness level here. It comes out a little bit darker than it should. The middle here shows you, if you see it on the screen, a car, because what this actually is a screenshot from an in-car infotainment, in-vehicle infotainment system, as the jargon goes, an IVI. The car industry is very interested in being able to build fancy user interfaces and fancy applications that run on the car, that give you information about the car and that keep you entertained while you're being driven or while you're driving. And guess what? They are doing that with HTML5 APIs and JavaScript APIs. This is an example from a slide from a workshop that we did about half a year ago, where the automotive industry came together and talked about how they could benefit from HTML5 and JavaScript. And so this example is sort of interesting because it shows things, both shows things that they're being very careful about and shows things that they talk about but don't at least do in their examples. So things they're careful about, this is, for the moment, just a read-only API. The web application just talks to the tire pressure sensors. Things that they talk about is the interaction model here. Alert is a wonderful JavaScript feature for examples and proof of concepts, except you don't want a modal alert of any sort while you're driving a car. So they're having some challenges ahead there. What is interesting again is careful scoping to read-only APIs, careful scoping to information of the driver for the moment, but even there, we might be talking about information that's really critical. You actually want to know this if you're about to drive a heavy moving van through the rain. The architectures those guys come up with are careful and are also something to look at through the eyes of a penetration tester or through the eyes of a security person. They're building at the moment on essentially a hybrid approach where you still have a lower level that is sort of platform native feeling. You've got a vehicle network stack. What could possibly go wrong? You've got a network manager, and you have a web runtime, as they call it, with web apps above. And again, the frame of the thinking is a lot about trusted apps and apps that are coming in through a distribution channel that is not the web, that are siloed away from the web, but we'll see. To just put a little bit more meat to that, this is another example of what that sort of architecture looks like, and again, HTML5 as the application system. Now, they do think about security carefully. They do think about sandboxing. This example shows the Tizen security model, which is used in cell phones and cars and the like. They're careful about that, and they're also careful in general about trying to think about what the security model looks like as you build web applications that are really local applications developed in HTML5 and in JavaScript. This is, by the way, a specification that I would love you guys to review, where I think we can use a lot of attention and a lot of additional input. The idea that those applications that are running on devices and on cars are somehow separate from the web also shows up in places like the attempt to build an app URI scheme. This is essentially giving you a way to think about the same origin policy, which usually you know about in HTML5 with an HTTP URI in a context where you have several instances of an application, and maybe each of them has a separate origin in that URI scheme. And again, this is just a URI scheme, but actually a really important part of the security model that those guys are thinking about. It's important if you think about using things like post message. It's also important if you think about things like control flows between different frames, control flows between different apps. So again, I would encourage you to take a very close look at these specifications. There's another point here that this particular story a little bit ignores. And this is yet another slide from that web and automotive workshop. And down here you have things that sound very much like the in-vehicle trusted app model that I talked about. You need to take your car to maintenance, preferably well before the lifetime of that brake is over, or preferably well before the lifetime of some TV screen in the car is over. Maybe you're told about your driving style and about driving, thank you, about driving in a more eco-friendly way, or you get maps, though that already gets interesting. But what is the very first bullet point on that slide? It's integration with your social networks and keeping connected. And I think that is one of the predictions I would dare about this model. We're not going to just see HTML5 and JavaScript, the technologies, as a platform. I think we are going to see the use of those technologies as a platform in relatively short order merge with the web as a whole, the web as this connected and linked and mashed up thing that brings us all those wonderful social connections, but also all those wonderful security headaches. I think we will see this particular set of technology go into that direction. And we've seen this story before. We've seen it with products like the bathroom scale that lets you do personal tracking and that then lets you automatically tweet your weight. We've seen it with the personal fitness ecosystem, where people are logging their runs and where you have a whole ecosystem of sites that let you share and evaluate all of that information. We're also seeing it with other personal tracking devices. The examples here are a Jawbone Up and a Fitbit. And it never works quite as expected. Fitbit had some interesting data leaks that were Googleable through their websites when people got confused about the context that they're writing for. In fairness, they dealt with that one pretty quickly. We are also seeing that we're seeing a similar story in the entertainment world. We're seeing a similar story with with the entire web and TV environment, where again social integration, in other words integration with other services on the web, publication of data, pulling in of data, meshing up across platforms, is one of the critical talking points. Back to the automotive, we're not just talking about staying connected with a social network, we're also talking about fundamentally useful technologies as we're driving. Take an example. How do you get here? You're using a navigation system that probably looks a hell of a lot like this, and in some cars these days, this is what you see in the dashboard. By happenstance, got to see a Tesla a couple of months ago, and of course it was showing web-based mapping. And what that points at is another reason why we will see those devices and HTML5 and JavaScript apps connect more and more to the web, and that is the raw computing power that becomes available in the form of software as a service, in the form of services built on massive amounts of data. And so we're not going to have just the HTML5 and JavaScript programming model. We are going to see the web as an environment and as a platform in those places and on those devices that are not browsers and not computers as we think about them, and we will get all the work and all the security vulnerabilities and plenty of new challenges exactly there. I want to talk a little bit about interaction models, because those are changing too, and some of that got foreshadowed in what I talked about already. But to take an example, and again, this is badly visible, and my apologies for that, but this slide, if you could see it, would show you a laptop screen here, a little tiny box connected through a USB cable here, and some hand up here. It's another marketing shot, of course, but it's a company that builds this little motion sensor that you can connect to your laptop, where you no longer touch a screen or touch a trackpad, but instead stand in front of your slides, and as if you were in some of the movies of the mid-2000s, just flick the window along or tilt something in a computer game or whatever you want to do there. The important thing, though, is these are interaction models that we are already seeing applied to web applications. These folk are already working on how to integrate their motion sensing technology with web applications, with APIs for the web, and that changes fundamental assumptions in how we interact. And I think that will actually matter for security, and I'll come to that in a moment. Another example, of course, is technology like Google Glass, where you interact through flicking your finger at the side of your glasses, or putting your head into your neck in a very weird way, or just talking to the thing, or even blinking. These are very different models, and these are interaction models through which you are going to interact with your web applications and with any security technology in the web application, prompts, passwords, etc. And of course, you have wearable technology that you carry. You have voice-based technology that you currently see in places like Siri, but that are also making it into other places like the search engine in your browser. Another of the challenges that are coming our way in the general environment are personalization models. There is no reason why a trash can shouldn't be able to recognize what your cell phone's MAC address is that it broadcasts in Wi-Fi probe packets. We're seeing the combination between personal information and public information in places like search engines or personal assistants, or search engines being both. We're also seeing devices that, in personalizing and through the interactions, build on motion sensors on an entirely different scale. Think about Connect. That thing sees what happens in your room. It recognizes a body. it turns that into technology that interacts with the web. Think about some of the modern TV sets that use your face to personalize the viewing experience. So if you're sitting in front of the TV, you get a different program than if your children sit in front of it. And all of that together leads to some challenges. If your computer just listens to the voices in the room, the access actually to that, the command line, is no longer just necessarily limited to the one person sitting in front of the keyboard or to the one person wearing the gadget. I hear that saying this in close proximity to somebody wearing glass has a very interesting effect on their ability to use the device after. And where that goes, of course, is what are the authentication models? What are the authorization models that actually can work in a world with these sorts of interactions, in a world where we no longer just have a keyboard. We're seeing a few ideas floating around. We're seeing people, as the Kickstarter, develop NFC rings, so you have a ring, and when that is close enough to your laptop, then perhaps your laptop will unlock, or your device will unlock, or your car will be personalized according to your preferences. We're seeing in some of the recent cell phones little dots that you can put like in your bedroom, and the cell phone knows it is in your bedroom, and so you don't need to enter a PIN code when the alarm goes off at the wrong time in the middle of the night or anything like that. We're seeing NFC technology used and starting to interact with the web as a way to authenticate. And of course, I mentioned the face recognition as a tool for personalization first, but it's also something that you can use to start thinking about authentication and authentication models for the web. What is universal today and what we actually have the standards for and what we actually know how to use in web applications, unfortunately, is a little bit less pleasant. If we're happy, we have strong passwords. If we're happier, we perhaps have two-factor tokens. Okay, that contrast doesn't quite work, sorry. If we actually try to use those tokens, this is the one I had to use with my bank, you go through complex activation procedures. The complex activation procedures require non-standard pieces of the platform that you really don't want to use and that you are certainly not going to be able to use on a device that doesn't have the computing power or the usual operating system that those things might assume. So one of the huge challenges here is how do we build authentication technology that works as part of the web platform, that works for web applications, is reasonably easy to program against, and that actually works if the interaction I have is flicking a finger there or pushing a button on a remote control for my TV or some in-vehicle entertainment system or infotainment system that I push a button on while driving across the highway at 150 km per hour. Execution contexts are another important piece of the puzzle and another important piece of the challenges that I think are ahead. We are currently often thinking of a web application as something that runs on one browser. I have it running on my laptop, I have perhaps another example running on a cell phone, but fundamentally I look at those as separate applications. As long as the state in an application is all happening on a server, as long as I have a very lean UI, that's probably fine because all I'm doing is state transitions on the server anyway. The good old RESTful model actually scales pretty wonderfully to applications that run on multiple screens. But that's not where we are going. We are going into a world where we have the 3.5 megabytes of JavaScript that constitute our mail client. We're going into a world where we talk about technologies like indexed DB and local, previously known as local storage, to store an increasing amount of state on the client. We have this contradiction between using web technologies that are optimized for a stateless client, moving away from private client state, but also we are acquiring more client state within the platform. We're starting to read email offline in a web mailer or in a web-driven office suite, for example. And if we have that sort of environment, then some of the environments that are coming our way are becoming less pretty, because what we are going to see are devices that are multi-tenant, devices where personalized content, personalized applications are executed using web technologies based on some trace, based on some identifier that we hand to them, perhaps willingly, perhaps unwillingly, as was the case in the London recycling bin story that hit the papers a week ago. But we are going to have personal content there. There are eventually going to be pieces of web applications that execute on these devices that we might consider sensitive or private and that we want to protect. How do we do that from a technology perspective? How do we deal actually with web applications executing on more and more multi-tenant devices? How do we deal with a piece of a web application being represented in an in-car entertainment system? I don't think we know that, and I think that the way in which we're heading toward more client-side state actually makes that more difficult and creates new challenges. So what I would expect is to see work on more synchronization of web applications across different browsers. We're seeing initial pieces of that in places like Firefox, like Chrome browser, like Chrome Tab Sync, like iCloud's tab syncing between Apple's cell phones and their browser. We're seeing those currently in a way that creates new silos. I think we are going to see eventually work that tries to standardize that. And we're going to see we are going to see Martin threw me off, sorry. We're going to see work that standardizes that, and we're going to see additional challenges about how to do that securely and how that all might interact with web applications that hold more security sensitive state. And this is an example from a study in the advertising world. We are already seeing a lot of people interacting on multiple screens. The standard example is from the TV world, where somebody watches a movie or a TV series and at the same time interacts on their laptop and on their cell phone and maybe tweets about the thing or follows a hashtag or pulls up a character bio or whatever. Marketing industry is on it. I think we're going to see some of that come up in the form of what I would call multi-headed web apps. And we'll need to ask ourselves, is it just another display, perhaps a strange display? Are we going to see really interesting synchronization technology come up? Some of that is happening in the background of the gaming world. It's happening with the background of wanting to have shared document editing. How do we think about those things from a security model perspective? How do we think about those browsers from a security perspective? And how do we deal with the authentication challenges around that in a way that actually works for users and in a way that is actually secure? I want to talk a little bit about monetization of the platform and other observers that we have, because I think that is another challenge that we're collectively seeing in the way in which the web as a platform develops and in the way in which security for the web as a platform develops. I already mentioned the multi-headed web applications, and actually this is really an infographic from Ad Age, an advertising trade site, and they're trying to figure out how to track you across devices. They're trying to use your TV's social functionality to better market their content or better bring their advertising to you. And again, the multi-tenant device called a recycling bin was actually meant as an experiment to see what sort of movement profiles they could get out. So what that company did was they collected data about the cell phone MAC addresses and built movement profiles. So they could say, oh, this person is returning to Starbucks, or this person is suddenly starting to avoid Starbucks, or this person is regularly passing by this particular shopping front, but for heaven's sake, they're not entering there, but they're lingering for 10 minutes in front of the exact same thing. What's going on? How can we market that better? It turned into a huge scandal. The Information Commissioner in the UK chimed in, the press chimed in, and they pulled the experiment pretty quickly. But I think we will see that sort of thing. We will see offline tracking integrate very closely with online tracking, and frankly, if you compare those with things that are happening inside stores, it's actually a little quaint. I couldn't imagine the same thing not happening in the vehicle space, where you have a pretty good idea about the driver's needs because you know what they have done recently, you know what their car will need next, you know when to tell them that there is a gas station and when not to tell them. There's plenty of interesting targeting one could do that way. And why am I bringing that up? The reason is that online tracking and online targeting and the number of third-party sites that we have in there creates two interesting challenges already, and that is without all of the new technology and with all of the developments that we are starting to see. One of those is the risk of, shall we say, an arms race. There is a lot of controversy going on between those who say ad targeting and ad tracking is a wonderful way to monetize content, to fund and to pay for the long tail of content providers, and to really get the best value out of online marketing. And those who say online tracking and targeting actually is deeply intrusive into personal lives. And some of those fault lines run between those who build browsers and those who market content to users. Some of those fault lines are between regulators and marketers. Some of those fault lines run within companies that have several of those identities. And one risk here is that we see ill-considered technical means that turn the platform less stable and make it harder to develop for it in general. The other risk that I want to briefly mention is the fact that we're having a lot of third-party content and third-party scripts here, which are in many ways the things that pay for the content. As we develop security technologies like CSP, that's actually a really important thing to keep in mind. Collectively, if we build security technologies that work great, and those technologies make some of the advertising stuff impossible, guess what will win in the discussion about deployment of either something that makes money or something that makes the site more secure? And that's another thing to keep in mind. How do we square the circle between those two needs? I think that's an area with quite a bit of work. The other point in the monetization and other observers part are the other observers. What's interesting, about 2 weeks ago, 3 weeks now, the IETF met in Berlin, the Internet Engineering Task Force, and some of the agenda items included the way in which WebRTC interacts with gateways to the traditional telephone system, and the way in which keys are managed in the context of that interaction. Another piece on the agenda were some of the security requirements in HTTP 2.0 and some of the security requirements even, or documentation even for HTTP 1.1 biz. And in the middle of the week, The Guardian published the Keyscore story, and on Wednesday evening, plenty of the security people there met in an evening session and actually heard a talk about what had been leaked and what was there. And those guys got shaken a little bit because there is an attacker model that some of us always knew there was, but also we often came with tinfoil hats. And that is the attacker model of a universal passive attacker, which is often something that in the design of protocols and in the design of platforms wasn't solved for. And that attacker model really being driven home as something that is in production on the internet right now, changed the discussion in several of those meetings during that week, and actually changed the way in which the ITF crowd started to think, for example, about key management for WebRTC. So I think we are going to see an interesting challenge of how to deal with a world in which that attacker model exists from the perspective of how does it change technology development, how does it change priorities in some of the technology development, and also what is the balance and how do those who are doing surveillance going to interact with all of that. I think that will be an interesting piece as we head into a future where more personalized content, more personal identifiers are going to be out there, where we execute applications on multi-headed devices and in more complex contexts, and where we interact with them in a more personal way. So I think there's a good amount of stuff to come here. To summarize, our headaches for the next, I ended up saying 2 years, the original draft had 5, but I don't think I have any idea what will happen in 5 years. Our headaches for the next 2 years, I think, are going to be the devices that we run technologies on and that don't feel like a computer or like a cell phone. Cell phones are starting. The things that are getting really interesting are cars and TVs and your home entertainment and your glasses and, in other ways, things that tie to your body and tie to your everyday interactions. So new interaction models, how do those influence security technologies? How do we build standardized, agreed, scalable authentication technology for those interactions? How do we deal with web application and security models, web application execution and security models as those applications move to being multi-headed, as they move toward executing in multi-tenant environments even more than we have that now? Briefly back to the authentication point, how do we make that seamless and non-cumbersome, because there are many hacks we can make work but won't. And our final headache for the next 2 years, of course, is that all of the predictions in this presentation will prove wrong, and we probably have no clue what's coming. Thank you.
Thank you, Thomas. And I think we have time for questions, if there are any. So it appears as if you have made everybody very scared of our future. Or they think the future is in good hands with people's standardization, and now that we take this use. So if there's nothing on your mind, then I invite you to have another coffee and wait for other technical sessions. One question. Ah, there's a question. Okay.
Thomas, 10 years ago we lost the classical perimeter.
The classical, I'm sorry?
The classical perimeter paradigm for networks. Do we now lose the classical perimeter paradigm for user interaction with keyboards and screens?
I think we've basically already lost that one. I think you're exactly right that if we interact and authenticate through voice, through gesture, through face recognition, through NFC device, we have much more fluent parameters where, as web application authors, we have much less control. And I think that will be a very interesting piece of the seamless authentication puzzle. For some of those devices, you don't want a parameter because you don't really want to have to crawl up to your TV set in the living room or to your game console or whatever it is. For others, where things become highly personal, you may very well wish to have that, and how do you actually talk about that in an application? How can you program against it is going to be pretty interesting. I think we're going to see the return of some biometrics. Actually, if you look at some of the press reports, apparently we're about to get ourselves an iPhone with a fingerprint sensor in a couple of weeks. So we're seeing some of that come up. We're seeing a lot of talk about NFC interactions, where again you get questions about what the parameter is, but some of that could be very close. But in the end of the day, expressing that, getting the right guarantees and being able to demand the right guarantees will be a very interesting challenge. And if I were worrying about banking security, I'd scratch my head and lose some hair.
Good. So then let's thank Thomas again.
Another hand. Okay. Thank you.